Okay, now we shall see about the the characteristics, or we can say the property where the polar and non-polar dielectric behave in an applied external field E0. Okay, so first let us have a look at non-polar dielectric. So again, I hope you still remember, non-polar dielectric means the center of positive and negative charges is the same. So these are the molecules of a non-polar dielectric. Okay, now when no electric field is applied to this non-polar dielectric, then these non-polar dielectrics, they will not possesses any electric dipole moment. So each molecules of these non-polar dielectrics, they will not be having a electric dipole moment when the electric field is not applied on them. But let us say an external field E0, it is acting on this non-polar dielectric in this direction, which we have shown with this arrow. Now what happened here is the center of the positive and negative charges here will get separated. Positive charge will be moving towards the field E0, negative charge will be moving towards, against the field E0. So each molecule, right, the center of positive and negative of each molecules will get separated in this direction. So finally we can see here that each molecules, right, now they are possessing a permanent dipole moment, because the center of positive and negative are separated. So therefore we get an electric dipole moment in each molecules here. So we can say that this non-polar dielectric, which was which do not have a dipole moment before the applications of electric field, now they show electric dipole moment under the actions of electric field E0. Okay, now similarly, when you look at a polar dielectric like this one, in polar dielectrics, right, we have the center of positive and negative charges do not coincide. So these are the centers. This is the center of positive, this is the center of negative of this molecule, this is the center of positive, negative of this molecule, right? So therefore we can see here that these molecules, okay, they have a different centers of positive and negative charges. So each molecules here will possesses a permanent dipole moment, but the dipole moment of these molecules here, they are not aligned in one direction. The dipole moment of this molecule, it is acting along this direction from negative to positive. Dipole moment of this is acting in this direction. Dipole moment of this is acting like this, like this, like this, okay, like this. So we found here that the dipole moment of each molecules of a non-polar dielectric, they are randomly oriented in different direction. So this happened normally when there is no applied electric field. But when you apply an electric field, let's say E0, in this direction to this polar dielectric, you will find that the dipole moments of all these molecules now will be aligned in one direction. Like the dipole moment of this dipole of this molecules will be acting in this way. Dipole moment of this will be directed in this way, in this way, in this way, in this way, in this way. So what do we see? We see that under the actions of external electric field E0, both non-polar dielectric and polar dielectric, they are having a permanent, they develop an electric dipole, and the net dipole moment, okay, of these dielectrics, of these two dielectrics, they are acting along the directions of the applied electric field. The net dipole moment here is acting in this direction, along the field direction. The net dipole moment here also is acting in this direction. So we conclude that both polar and non-polar dielectric, they develop a net dipole moment in the presence of external electric field E naught. So this fact is called the polarization of dielectric.